Hello, and welcome to the walkthrough of Rendered AI's Warehouse channel. This is a demo channel created to show off Rendered AI's procedural environment and computer vision capabilities. To begin, log into your Rendered AI account. If you do not have one, begin by creating one. We will then create a new workspace, navigate to the top right, and select the green New Workspace button. Next, we will input a name as well as boxes as our content code. This will populate our workspace with preset graphs and settings that we can use for our warehouse channel. Once inside our workspace, we have a few different graphs that all have different preset parameters. Let's hop into the large, random-sized, high-density warehouse graph. Here we see a lot of nodes with a lot of links, but let's not get overwhelmed. Our main node is the warehouse environment node that generates our warehouse environment and populates the shelves with random objects. The parameters are as follows: size x and size y, an integer value which sets the warehouse's size in the dimension where x or y is equal to 2 meters. Height, an integer value which sets the warehouse's height where z is equal to 4 meters. The input sockets for all of these have a random integer node plugged in. These nodes will select a random integer inclusively between the max and min settings per run. These nodes can be found under Common, Random, and you can choose what type of value you want for the node. In this case, we either want random uniform for float or random randint for integers. Shelf object density, a float value between 0.1 and 1 determining the amount of objects found on the warehouse's shelves, where 0.1 will have almost none and 1 will have full shelves. This is the high density graph, so it is set to 1. Shelf spacing, an integer value greater than 0 that will set how far apart the shelves will be, where an input of 4 will place them every 4 meters. Brightness, a float value determining how bright the scene will be measured in watts per square meter. Note that while these values are physically based, the image will likely not look exactly as you'd expect if you're basing it off of real-world values, as our eyes will adapt to lights but a rendering engine will not. Floor object count, an integer value setting the amount of objects that will be placed on the floor in the scene. This value might be hard to determine from renders, as not all objects will be visible in a single render, but in general a higher value will give more distractors for the scene. Floor objects. These are the objects that will be scattered onto the floor as distractor objects. The inputs are volumes, and as many inputs can be added. Every object placed on the floor will be randomly selected from the inputted volumes. Here we have inputted 4 of the 5 options that can be found under the Objects, Floor tab. Shelf objects. These are the objects that will be placed on the shelves in the scene and given the annotation. The input is also a volume, and as many inputs can be added. Every object placed on the shelves will be a random selection from the inputted volumes. Skip empty scenes. A string input where yes will change the seed value for the scene until there are shelf objects in the scene. A string input of no will render any scene even if there are no shelf objects in the scene. Note that a low shelf object density value may produce a seemingly empty scene even with skip empty scenes toggled. This happens because either one of the few objects are behind a distractor object or shelf, or the object is just barely outside of view. Please do not input 0 volumes and then enable skip empty scenes, as that will cause the job to fail. Next, we have our cam settings node, which will provide the scene a camera. The sensor width and height are the pixel resolution values, and the focal length parameter will change the lens's focal length. Both this and the warehouse environment node need to be plugged into the render node for the job to function. Once you have the settings you want, you can stage the graph and navigate to the Jobs tab. Here you can see the graphs you've staged as well as some of the other preset graphs already here. To create a job, press the down arrow, set the name of your dataset, set the priority and number of runs. You can also input a seed value if you like the result from a different dataset. Once the job is complete, you can download the dataset by clicking this icon. The job will include 4 folders and 2 files. First, we will look at the images folder, which includes the RGB images that were rendered for the job. Next, we will take a look at the mask, which is an image mask with pixel data of where the boxes are in the scene. The annotations folder has JSON files that are text representations of pixel data for the boxes, and the metadata is a simple file specifying what the annotation bounding boxes represent. The graph YAML file is the data for the graph that was used for this job, and the dataset YAML file includes the information of the job itself. I encourage you to play and experiment with the settings of the warehouse to see the visual variety this channel can provide and what type of procedural generation we could potentially provide you for your computer visualization needs. Thank you so much for watching and have fun.